After the first break today, I think Frederick is coming in to give an announcement with regards to the bus leaving tomorrow. So just so that you know that he'll be here after the break. We'll start off by watching a clip. We didn't take the time to watch it yesterday, since it had been a long day for you guys. This is from Statoil, one of their newest field developments, Åsta Hansten.
Vi nå ferdig med marinesesong nummer 3 av 4 på Åsta Hansten.
Speaking in Norwegian, but they have
har I år
English text.
En veldig bra sesong, og alle rørledninger og kontrollkabler nå koblet opp mot Aker dypvannsstrukturer, som ble installert I 2015.
So you can see a lot of the
Åsta Hansten
wiring that they're
lokalisert
using
300 kilometer vest for
keep it in
Bodø.
place.
Havdypet 1300 meter. Dette dermed den dypeste utbygging på norsk sokkel så langt. Det kombinasjonen av dypt vann og røffe værforhold, det vil si maksbølger og strøm, som har gitt oss en del ekstra utfordringer, og en må være optimalt forberedt når en kommer ut. Spar-plattformen til Åsta Hansten bygges for tiden I Korea, og den skal slepes ut på feltet og settes I produksjon I 2018.
Årets offshore-kampanje bestod av 200 fartøystøgn og startet I april med mobilisering av Sound Oceans på Vigra. Installasjon av rørledninger og Steel Catenary Risers ble gjennomført I en kampanje som gikk over flere uker I mai og juni. Deretter mobiliserte Norman Oceanic I Sandnessjøen for spulinstallasjon. Spuls kobler sammen dypvannsstrukturene med rørledningssystemet. Spulene ble fabrikkert hos Aker I Sandnessjøen. Seven Viking foretok tie-in og commissioning-aktiviteter av rørledningssystemet, og rørledningene nå reservert og klar for inntrekk I 2018 når plattformen på plass. Til slutt mobiliserte Skandi Skansen for preinstallasjon av forankringssystemet til plattformen. Forankringssystemet består av 17 forankringsliner som ble installert på sjøbunnen, og som nå klart for hookup I 2018. Vi veldig fornøyd med at vi ikke har hatt noen alvorlige hendelser gjennom hele marinekampanjen I 2016. Vi ser også at kvaliteten som leverandørene leverer, både hos Aker og Subsea 7, svært høy. Vi helt avhengig av gode leverandører på et så komplekst prosjekt som Åsta Hansten, og det har vi hatt. Vi takker alle for de bidragene de har hatt I årets kampanje, og ser frem til fortsatt samarbeid mot 2018 når plattformen på plass.
So that's a completely new rig. So it's a spar rig, as it's called. In Appendix B, we're actually going to do a quick calculation on a spar type construction, which just basically means that it's going to be a cylinder, a vertical cylinder that's floating in the ocean surface. And that's how the spar platform is also created. As a cylinder that is going to be moving up and down with the waves, but it's going to be going to have less impact. The waves are going to have less impact on the movements of the rig than what they have on a regular vessel, like the one in the picture there. So, but as you saw from the clipper, they've already had 200 days of vessels working on this field. And the platform isn't even in place yet. It's going to come into place in well over a year, in 2018, which means that they are going to have quite a lot of vessel days working for 2017 also. So they're going to do a lot of preparation work before this rig comes into place. Because usually they do all of the preparation work beforehand, and then when the rig comes in, it is basically just hooking it up and getting all of the systems running, and then they can start producing. So there's no point in waiting for the rig to be finished being manufactured before you start hooking up everything. So you can start off having the entire field almost ready before the rig comes into place. So it's just a matter of drilling all of your wells and making them secure so that you won't have any incidents with the wells, and just making sure that you have all of the safety barriers in place there to make sure there won't be any spills or anything. And hook up as much of the equipment as you can before the rig comes in. You also saw a little bit, a couple of clips where they were laying cables and pipelines there. So in one of the clips, you could see the green pipeline going down into the ocean. So you can see it's not really fast when it's moving down there. It's moving very slow into the water. I think they only showed it in real time once. The rest of it was sped up. But usually it's very, very slow when it's moving in, because they need time to prepare everything when they're welding together sections and everything like that. So it takes time putting all of this in. This is one kind of pipe laying system, the flex pipe laying system. And you can see here you have a large drum with flexible piping on. And you have the flexible piping coming up here, and it is going through a sort of, it's called more or less a banana sheave. It's shaped like a banana, and it's going to control the motion of the entire pipeline as it's moving through it, so that it's going to have one continuous radius all the way around here before it starts on the downwards motion towards the ocean floor. So this is one way of laying pipes. We also have, so here you see a picture of it. Get to see a bit more how they look like. You also have quite a lot of different ways. As you can see in both the illustration here and in the picture here, the drum is sort of vertical, so that it is spinning along a horizontal axis when it's paying out the pipes. In this illustration, you can see that the drum is actually horizontal, so that it's spinning around a vertical axis instead. So it's lying flat on the deck and spinning around there. So that it depends a bit on how much room you have, of course. If the diameter needs to be really huge, it has to be vertical, because you won't have a wide enough ship to place it in. But as long as you have a wide enough ship, you can have it lying flat, which is going to be more beneficial for the ship when it's moving about, because you get the center of gravity for this drum of pipe is going to end up lower down. So it's going to ensure more stability for the ship. So that the combined center of gravity of both the ship and the drum, when it's horizontal, is going to be much lower than if you have a vertical drum. So you're going to, with a vertical drum, your center of gravity will be shifted upwards, and with a center of gravity that's higher up. Let's see if I'm going to try to draw in a vessel that's slightly tilted here. So this one is with the horizontal drum, and try to make a fairly similar one here with a vertical drum. So with the horizontal drum, we might have a center of gravity. This is just guesswork from my part here, but we will have a center of gravity approximately here, which will be slightly to the side of the center of the bottom of the vessel. So it's going to push it more over to the side. You are going to have gravitational force pushing down here. You will have buoyant force pushing up here, and gravity will be pulling down there. So you will have a rotation in place here. But so long as the gravitational point stays, the center of gravity stays fairly close to the center point of the vessel, it's not a really big deal. because you're going to have forces working on your vessel, but it's not going to tilt it all the way around. But the problem is if you're starting to get your center of gravity way up here, because you have so much weight up here in the drum, then suddenly the center of the ship and the center of gravity, you're going to have two force vectors that are pretty far to each side. That was the wrong way. And you're going to have a much more powerful torque on your vessel. And if the center of gravity gets moved even further up here, it's going to come fairly close to the outer edge of the deck, and then you can actually have the entire ship twist around. Then when you start adding in waves and impacts from waves and all of the motions that a ship will go through, you can have a pretty dangerous situation if you have your center of gravity too high up. So ideally, you would want your drum horizontal on the deck in order to have it as stable as possible when you're working. And here we can see a typical working operation. They're paying out the pipeline. It's being put through sheaves here. It's pretty difficult to see it, but there are sheaves on the banana-type sheaves here that are sort of guiding the pipe in the correct radius over the edge of the ship, and then down to the sea floor where it's being put into place, and an ROV is monitoring the area where the pipe is touching down as it's moving along. So the ROV is following the point on the sea floor where the pipe is touching down constantly, just to make sure that it's hitting the correct spot, especially if it's supposed to be down in a trench. So if they have pre-made a trench beforehand, and then they're putting it down and they want it to be placed inside the trench, maybe they're going to cover over it afterwards, then it's especially important to have the ROV down there to keep an eye on and make sure that it's ending up in the trench and not going over the side of the trench and beside it. So it's important to have the ROV there and keep an eye on things. Here is another kind of pipe laying vessel, and it has in this case, it's more, this is the kind of vessel where they have 12-meter long pipe sections, really huge, and they're welding them together up on deck here as they are moving them along. So it's even slower on these ones. And you can see it's a semi-submersible rig. So it has the platform legs here, and it has submerged pontoons underneath. And it also has in the back here, it has a large stinger. Because once you have welded pipes together for your pipe, it's not a flexible pipe anymore, it's a welded steel pipe. It's not going to be able to handle that much radius as you could with the previous ones here, where you could put it through a banana sheave, basically. So for these ones, you have what's called a stinger instead, which is almost going straight out. So it has a slight curve to it going down into the water, and it's going to follow the pipeline for a bit into the water there, below the waterline, and then the pipeline is basically hanging there freely from the end of the stinger and all the way down to the ocean floor. And these move very slowly forwards because, of course, they have to weld all of these pipes together as they are moving along. And if you remember from the remote welding habitat, they said that depending on the diameter of the pipe, it could take up to 2 days of welding just to get one weld in place for the pipes. So it takes quite a lot of time when they're working on these. I'm not quite sure about this ship, but I know that a couple of them, they are actually welding several pipe lengths together in one row, and then they move forwards a bit, and then they can put a couple of new pipe lengths in there, and then they weld all of those into place. So it's quite of a time-consuming process doing this kind of work. It's going to take a lot of time, and considering that just for the Langeled pipeline from Ormen to UK, 1,100 kilometers divided into sections of 12 meters. and you have to weld every 12 meter. That's an amazing amount of work that was done. But I think they had at least 4 or 5 different vessels working on that one when so they were working at different sections. They were putting them down, and then they were connecting the sections as they were completed. So it is possible to get it sped up as long as you're willing to use the money to pay for several vessels and having it happen a bit faster. There's also another kind. This is more of a cable laying one, I think. It has the horizontal drum there, and it's also using echolocation to see the depth, just in order to know how long of a stretch it's going to have on the cable. It also has a device that's connected to the cable after it's left the wheel on the back, and that device is basically telling them of the angle of the cable, just to know and that it's being sort of behaving as it should as it's going down. If it's somewhere along the bottom should snag on something, it might be that you would get a more of a slope instead of a steep angle going downwards, because then parts of the cable would snag a bit and you would have tension in the cable. And then it's of course important to keep an eye on that angle indicator, just to know that something's up. We have to have the ROV needs to move a bit backwards, see where do we have something wrong happening here. Something has snagged the cable or anything like that. So they're using quite a lot of different technologies. They also have a dynamometer on the wheel, just to see how quickly it's turning, and they also have meter and speed counters, just to see how quickly the cable is being paid out, because that's important when they're putting it down, to make sure that they're getting it all correctly. So this would be typical for electrical cables, whether they are between nations in order to transfer electrical energy, or whether they are from a shore and to an offshore installation to provide land-based energy, which is starting to become a requirement from the Norwegian government now. Instead of using gas turbines on the offshore rigs, they now want them to be supplied with electricity from land instead, because usually the gas turbines they have quite a lot of CO2 emissions, so they want to get the CO2 emissions down in the offshore industry. But also for electrical cables being placed between different subsea modules, so subsea structures, and you're connecting them together, and all of them are going to need power. So all kinds of cabling is done with vessels like this one. And here we have the heavy lifter, the Saipem 7000, which we talked about yesterday. So I've actually seen that. So when you're driving from Stavanger and north to here, so before you get to the underwater, the subsea tunnels on the way to the ferry, you could actually see it in the harbor. So even though you were in the highway, way off from the harbor, you could see basically from here and up. So you could see that past all of the houses and buildings and everything that's lying there, past the industry areas and into the harbor there, and then you could see all of that sticking up. And even from way further south in the over in the forest area, where they have all of the industry, the Statoil have their offices and everything like that, you could actually see the tops of the cranes. So it's a massive ship, that one. I have also put in a clip because we've had in the recent years, we've had a rather scandalous rig that's been put into place, which is called Yme. And it hasn't produced a single drop of oil, and now it's being decommissioned. So there was quite a lot of stuff going wrong with that one. And by the time they got it in place offshore, the supervisory agents from the Petroleum Safety Agency who came out there, they said that, nope, you have to fix all of this. They had a huge list of stuff that had to be fixed before they could start producing. And in the end, they figured out that basically it should have been just dismantled and built anew because it was too poorly designed and too poorly done. So they had to remove it, and it's 13,000 metric tons. I've seen 13,000 and I've seen 13,500, so I'm not quite sure which is correct. So I put in the smallest one, and they lifted it away in 60 seconds. So that's all it took. Of course, they had a lot of preparation work that needed to be done. So they had this ship from a company named All Seas come in, and it basically has a huge opening in the front of the ship. So it moves in and is basically sort of straddling the rig. And then they cut off the legs of the rig. The closest one here remains there, I think. They left that one standing. So they cut the 3 inner legs of the rig and they lifted off the main module of the rig. And they did that by getting these sort of huge jigs on the ship in under the rig, and then they sort of just lifted the entire ship after they had cut the legs of the platform. So first off, before they moved it in under, they of course probably filled up all of the ballast tanks to get it as deep into the water as possible, the ship, and then they moved it in underneath, cut the legs, and then they pumped out all of the ballast water so that they could lift it up. And here we see it. So there's the one that was closest to us in the previous pictures, staying there, and then they've lifted all of the rest away. So 13,000 tons in one go. And here we can see a clip from it. It's a fairly long clip, so I'm going to fast forward every now and then in it. So here it says 13,500 tons. It's a pretty huge ship. First they sort of back up the ship to the rig, and then they're going to place the cutting tools in there. So they lift the cutting tools onto the rig, and then they're going to go into the rig and then into the legs of the platform, and they're going to mount these cutting tools on the insides of the legs. Fast forward a bit, we don't need to see all of this lifting stuff. Jump to here. This is where they're actually moving into. Now they've gotten all of the cutting tools in place. They've lifted everything on and gotten it into place there, and they're moving the ship in. Actually, the platform is rotating due to the effects from the waves, which means that they need to actively compensate for the rotating motion in these jigs that are connecting to the underside of the platform. gently remove the rotational movement after they've gotten the connection. Massive hydraulic systems in here doing all of this work. Here you can see the yoke itself is moving with basically with the ship, because the ship is moving up and down with the heave motions while the rig is standing still. So the rig is only rotating a little bit with the waves. And here you can directly see the active heave compensation system working in here, trying to counteract the motion of the waves at all times. Now they're pumping out the water from their ballast tanks in order to get more buoyant force on their ship, which is going to start pushing upwards on the rig. And now they start cutting it from the inside. As you can see, the cut here, they're making sort of a tooth pattern when they're cutting it. And my guess is that that is to ensure that the platform will stay in place until they've actually started lifting it, and all of the weight is resting on the ship and not on the legs of the platform. Now all of the weight of the rig is resting on the yokes and down on the ship itself. And it just backs away from the platform legs very slowly. I imagine being a part of an operation like that, actually being on the ship, is going to be sort of like an anticlimax, because everything is moving so very slowly. It's very interesting when something's happening, but then you have a long wait because everything is moving slowly. So I think it's going to be a sort of a trial of everyone's patience when you're working like that. So here they're getting it moved away. And I think the last part is when they're taking it, moving it ashore and then transferring it to a barge. So they now moved it into shore, and now they're going to lower it down onto a barge. And if I remember correctly from the last part of the clip here, they're actually going to pull the entire barge onto. Either they're going to pull the barge onto shore, or they're just going to put it onto shore and then move it onto the rail system or something. I'm not quite sure what they do. But if you're thinking about the center of gravity for that barge, it's pretty high up, so you really don't want any waves coming in when you're doing an operation like that. Yeah, they connect the barge to a harbor, and then they align these rails and they move it ashore. And I'm not quite sure what their plan is with that rig. I think some of it is to because there is a company that's bought the decommissioned rig. And I think some of the plan was to sort of dismantle it and use most of the processing equipment anew somewhere else, because if I've understood it correctly, and the operational hazards with that platform were in connection to the safety of the platform itself. So there's something wrong with those legs. They're not correctly in place. I think it was something like the concrete they poured on the base for the legs. It was supposed to dry off within a couple of hours, but used several weeks to dry off, which has I think it's set in a wrong way or something, so that there is something going on with the base there, which meant that it wasn't safe to have people working 24/7 on that platform. So the processing gear and everything is supposed to be all fine. So hopefully this company who has bought the old rig will be able to, or the new old rig, because it haven't been used yet. So hopefully they're going to be able to use at least parts of it in a newer rig that's going to be placed somewhere. Because this one was it was placed out in the North Sea when I was doing my studies. I think it was in 2012 when I was doing this course myself, because there were sort of whisperings on the wind about a scandal happening with this platform then, but no one wanted to really talk about it in the industry, because they felt that they didn't want to say something that was going to be interpreted incorrectly, because they didn't have all the facts of it. But then, as time progressed, it's been up in the media and everything, and it's been a huge blow for the company that was supposed to build it, and the company build it correctly, and also the company that was supposed to run it. So they're at each other's throats right now with legal actions and everything, trying to figure out who is going to pay all of the billions of Norwegian kroner for this scandal. So sort of a pretty hefty situation for those companies. With the field, I think they're going to place to actually do something with the field as they're going along. But I think for now, the company that was supposed to operate this platform are still the ones that are supposed to operate the field, which means that they have to get this platform into the history books. So they have to finish off what they're doing here with regards to legal actions and everything before they can actually decide to commission another platform to replace it. So it's going to be interesting to see in the coming years how this legal struggle is going to pan out. Who is going to have to sit there with all of the bills to pay afterwards, because just the removal of it is pretty expensive. And then you have the building of it, the transportation. I think it was built in South Korea. I'm not quite sure about that, but it wasn't built in Europe, at least. It was built somewhere else. It might be actually that it was built in the Middle East when I think about it. But at least it wasn't in Europe that it was built. So it has been transported across large portions of the globe already to get to here and just sit out there in the North Sea for a couple of years without doing anything, just rusting, and then being removed again. So it's pretty almost heartbreaking to look at this story, how something can go so terribly wrong when you're just also thinking about all of the thousands of people that have been working on this to get it there, and then nothing happens. It's pretty amazing. We'll start looking a little bit at requirements when we are choosing what kind of vessel we need for an operation. We have 5 minutes before the break, so we'll just start looking at it. So the first things we need to think about when we're going to choose a vessel is exactly what task is the vessel supposed to do, and are there any alternative methods of solving that task. So for an example, are we going to do maintenance repair on a subsea production unit? So a subsea structure, we're going to do some maintenance repair there. Alternative methods of solving the task. We could do it purely with an ROV. If it's not too deep, we could also use divers. So what are we going to choose? Are we going to choose a vessel with ROVs or a vessel with divers? Or maybe do we need to combine them? Is this an old field where we're going to do some repairs, where parts of the field really needs divers in there, but maybe just a small portion of the operation actually needs the divers there, and the rest can be done by ROV, which is a cheaper solution by using the ROV, so that then you could have the divers come in and perform the tasks that have to be done by divers, and then they can move off to another job if they have one in the queue, and then the ROVs can keep on working on this field. So you have to sort of consider all of the different methods that can be used in order to solve the task at hand, because that's going to affect what kind of vessel you're going to choose. And you're also going to need to know all of the necessary equipment and tools that you're going to need, because it doesn't really help to show up to a maintenance job like that with a survey vessel and a survey ROV. You don't have the correct tools and equipment then. You would have to have work ROVs instead. So you need to know that you can't just choose whatever vessel has an ROV on it. Suddenly it's just as an observation ROV, it doesn't have any work ROVs. So you have to make sure that you have everything in place. And as we talked about with work ROVs also, there are different classes of work ROVs. So you can have smaller, lighter work ROVs, and they might not necessarily be able to use all of the tools that you need to use in this operation. If you have some specialized torque tools or equipment that's going to be used, a smaller work ROV might not have a powerful hydraulics pack to be able to run those tools, so that you would actually need a larger work ROV in that case. So that's also something that needs to be looked at when you're looking at what kind of equipment and tools are going to be used. Then, after this has been considered and you've sort of gotten all of your options straight on what's actually possible to use, then you can start looking at, for an example, what will be the required dynamic positioning level for this vessel. And that depends on how close to a rig does the vessel have to stay. The closer to a rig it has to stay, then the more safe the DP system has to be. Because if you have the lowest class of DP, which is the most unsafe, it's still safe, but it's the one that is most, that will, the entire dynamic positioning system will fail if one component fails in that system. So it basically has no backups at all. And using a system like that while you're 5 meters away from the legs of a platform, you really don't want that, because then if you suddenly have one component fail, the DP system fails, and it's going to take a little while for the operators on the bridge to actually notice that the DP has failed. By then you could already be just 3 meters from the legs of the platform and moving fast towards them, because that's how they are going to notice it, that they're actually moving. That's how they see the legs coming towards them. So, whoa, the DP system isn't working anymore. And that's really dangerous. So then you would have a collision on your hands and everything. So then you want a really safe dynamic positioning class. I think we'll stop there and we'll have a break. we'll continue after Fredrik has had his talk.
that some of you guys have a bit of problem in the morning being here on time with the buses and everything. Because I see you come running at almost 10 to 8:20 each morning. That's not the day to do that tomorrow, because then you miss the bus. And the thing is that we have told them how many is coming. So they are expecting the whole class. Right? And it's kind of embarrassing if you ain't there. Quite simply. And this, I mean, you are going to visit Statoil. You are going to the biggest company in Norway. Okay? And you will get a tour of the facilities in the bus. So you will come in and see the process plant. You will do a lot of cool stuff tomorrow. And, skal du med?
No, Runald and Torbjørn will join you.
Runald and Torbjørn will go with you. Okay? So they will be with you the whole day. Okay? And then you have the possibility to ask Torbjørn a lot of questions, because he worked there this summer. So he knows the place.
Well, he worked in a small part of that huge place.
He worked there this summer. And then we have something that's going to happen next week also. We are going to go to something called Cincy. That's a simulator center. That's just over there, where you will be able to try and drive an ROV. It's simulated, so it's not in real life, but it's big computer screens. It's quite cool. And you will see the tools that are used on ROVs, and you will also try to use the manipulator arms on an ROV. And that will be for half of the class. So those that have mechanical design on Thursdays, that half of the class will go on Wednesday. Okay? And the group that has mechanical design on Fridays will go on Thursday. And we will walk from here at 8:15. And the same thing there is that we are walking 8:15, right? So you need to be on time, because it costs us a lot of money to do this for you guys. It's not free.
This is not something that Norwegian students get to do.
No,
so.
This is a really special thing that you guys have the opportunity to do. There is the only persons that go there from this school are the students that are going to be captains on the boats. They go there to learn how to drive the boats, right? So this is a huge thing to do. Really cool. And the week after that, we are going on another excursion. So there's excursion, right? And then you are going with me in Kjell-Eivind, and we are going to something called the PRS base. That's the underwater base here in Haugesund. That is over there. So on the Wednesday, we will go at 1 o'clock from school. We will arrange a bus to take us, and you need to bring your passports. Because we need to show ID when we walk in there, because it's an international area. So it's truly heavily guarded. So it's really important that you have your passports. I don't think you need those tomorrow.
I'll check with Torbjørn later today to see.
You might need to bring them tomorrow also when you're going to visit the tugboats, because the tugboats...
Not for the tugboats. Those are in Norwegian waters,
okay,
so that's not a problem.
Because the tugboats have two docks. One Norwegian and one international. And if they were on the international docks, you need ID to come aboard.
But I'm not sure if they need ID in order to enter Kårstø, so that might be.
Yeah, but that we will get back to.
Yeah.
The trip I talked to you about Bergen, that won't be happening. And that's quite simply because the two companies in Bergen that we wanted to visit hasn't come back to us. And now kind of time is running out. We're in November, and it's a little bit more than 3 weeks, then this semester is over and exams start, right? So it's kind of short in time. So we do all these things instead.
But that being said, the two companies that we were supposed to visit in Bergen we will get the same by visiting the PRS base here and visiting the Kårstø.
Yeah.
So we will get to see a processing plant, and we will also get to see a pipeline repair system. So.
And how many of you guys are thinking of going home by Christmas? School starts the 2nd of January. Quite simple. School starts 2nd of January. That means that, guess when you're going to be here? Before the 2nd of January. Monday morning, school starts. That's life. The thing is that we start so soon because we need to get through everything, right? And it's no different from the Williams unit. They have exactly the same. They also start the 2nd of January. It's one of those years. This year, Christmas is truly short. It's something that we call a employer's Christmas, right? Because Christmas is on the weekend. So you don't get so many free days. So that's something to think about if you're going to order tickets, right? And you can't be late this time. I won't accept it. I'm serious about that. You guys being the ones that have been traveling have been a little bit too late the last times, right? Kind of 3 weeks and stuff like that. That is unacceptable. So I'm giving you a heads up now, so you know this, right? And you will have 3 subjects next year. Renewable energy and petroleum production. That's kind of a split subject that you're having this year. You will have math, and you will have mechanical design 2. And mechanical design 2, guess where you're going to spend a lot of your time? In the computer labs, right? But then you are getting other programs. You're getting SAP 2000 among other things. So there will be new computer programs that goes into it. Okay? You guys have any question about what's going to happen? No? Yes, there will be food tomorrow. Of course they will have food. Är det bara frasagt att några av dem är muslimer som kommer?
Det vet jeg ikke. Det må vi høre med Torbjørn. Ja.
No, of course you will get food tomorrow. We won't starve you, right? There will be food on Kårstø. So that's not the problem. They will stand for that.
Statoil are usually liberal with their lunches when you come visiting. So.
Hope for the best. And I will know if you're on your best behavior because I'm going to tell my wife to check up on you because she works there, right? No, just kidding. But she will see you from her office. Okay? So the really big thing tomorrow is that the bus leaves at 8 o'clock. So be here extra early, okay? And next week when we're going to Cincy, I will come to you probably next Tuesday also to give you the information about Wednesday and Thursday. But then you will go with me. I will join the groups both days and I will be at the simulator center all day. If there is anybody question.
Sorry, I just want to ask that because last week, is your wife working on this side or this side?
She's actually she's boss over the cleaning of all of Kårstø.
I just want to do this side.
It's a huge place. Do you remember when we went to Stavanger?
Yeah.
And we sat in the boat and I told you to look outside the window and saw all those flames. Yeah, that's where you're going tomorrow. So it's a really big site. It's actually the largest gas processing plant in Europe you're going to. So it's big. Lot of money going through there each day, so to speak. But the office is saying so big, but the plant is big. And when you're going through the plant,
safety, safety, and safety, right? Because if you are walking in the plant and something happens, and all of a sudden everybody goes, woof, one goes that way, and then one goes that way, and the third one goes that right, and nobody knows where they are going if something happens. So that's why they will have a guide in the bus, and they will show you everything that way, because you need special permits to be able to go out in the processing plant in Porsche. Not everybody that works there are allowed to go into the plant. That's how tough it is. But I think it will be a good experience for you to see what they are doing. Okay? So enjoy, have fun on the boat, ask a lot of questions. Here you have the opportunity to ask a lot of questions, right? This might be your future when you finish here, working with these things. So ask. And who knows, some of you might do your bachelor thesis out there, if we're lucky. Okay? So that's kind of why we need to be in the best behavior, right? Because you are being able tomorrow to sell yourselves, right? Okay. So have fun.
With regards to the tugboats next year, tomorrow, not next year, but tomorrow. Yeah, I'll do it afterwards. With regards to the tugboats, there is one slight possibility that you won't be able to see them, and that is if something happens in the coastal harbor, and both of the tugboats need to be there in order to, basically if there's an emergency, and they need both tugboats at the same time when you were supposed to go there and see them, then they have to cancel it. But usually, 99.9% of the time, one of the tugboats is in their harbor, so that it's possible to go and visit it. Because they have two, and usually they only need one. Sometimes for very large vessels, they need two in there, and if an emergency happens, they will have to use two. So there is a slight off chance that that part might not happen if something goes wrong over there while you are there. But then they are going to contact Torbjørn by phone and tell them that they won't be able to make it, or maybe that one of the ships will be returning a little bit later than what was originally planned, and that you'll just wait for half an hour and it'll be there. I think you'll go through that hurdle if it shows up, but I'm feeling pretty confident that the boats are going to be available so that you can go in and see. And I think I mentioned it before in the hydraulics lectures that their plan is to split you into 3 groups, and each group is going to get to see both the bridge, the deck, and also the machine room, so that you're going to get to see 3 parts of the boats while they're there. So I think it's going to be pretty interesting. Right, then we can continue on with requirements for our choice of vessel. So we talked about basically finding all of the alternatives available to us in order to achieve the task that's going to be done, and know that we are going to be able to operate and carry the necessary equipment and tools. We talked about the dynamic positioning class of the vessel, and with regards to necessary equipment and tools, we also get this one, required available deck space. Because if we're going to exchange a module on a subsea production plant, then we're going to have to have enough available deck space in order to have that module on deck while we are transporting it from the shore and out to the field, and that module will be unnecessary equipment. So this might affect the required available deck space on the ship, but also for other equipment that might be necessary to use. We are also going to have to make sure that we have enough required lifting capacity, so that we have enough strong enough cranes, and also that we have enough cranes. So it doesn't really help if we have one strong enough crane if we should have had 2. So Even though our one crane is capable of lifting the module, if we need two in order to stabilize it during the lift, then we won't get anywhere with just one. And that's where the stability check comes into play. Both with regards to the stability of the vessel, if you're getting too tall stuff on deck, but also with regards to stability during lifting, so that you're going to have it safe enough. Like the one we looked at yesterday with the pipe spool that was transported horizontally, lifted into the water, and then lowered somewhat down before it was tilted into a vertical position. There it was necessary to have both a crane and also a winch in order to be able to handle that one. So if that vessel only had the crane, they wouldn't have been able to do that operation. We're also going to have to check if we have the required crane capabilities, and that doesn't just regard the actual lifting capacity of the crane, but also what it can lift at different work radiuses. So basically, we all know that the further away from somewhere we get, if we have a force, so put in a new boat here. If we have a crane up top here, and we have something hanging down here, we have a weight that's pulling on the tip of the crane. And the further away this weight is from the crane itself, the more momentum we are going to expose the arm of the crane for. So the crane boom is going to be exposed to more momentum. And this means that often for cranes, they have a degrading lifting capacity the further away that you're lifting something. So if you're lifting a large module, so the module itself is pretty large, then you're going to have to be able to lift it far enough out so that you get a more safe space between the hull of the ship and the module so that you won't slam them together. And that's going to mean that you have to check how much lifting capacity the crane actually has when it's over here. So when it's lifting that far out, is it possible for it to actually lift that much weight when it's that far out? Because lifting it from the deck and over here, that's going to go completely fine because that's within the normal lifting capacity of the crane. But then when you start extending it even further, then you're going to start degrading how much it is possible for it to lift. And if you extend it too far and have too much weight on it, it's actually going to break in two. So you're going to destroy the crane and you're going to lose the module into the sea. So it's very important to be aware of how the crane works. We're going to look at a chart showing how it degrades with the radius, swing radius of it. We also need to figure out if we're going to need heave compensation. So basically, when and where are we going to perform this operation? Where we're going to lift with this crane? Can we expect there to be quite a lot of weather there? Will there be waves? Will there be wind? And if so, especially if you're thinking the winter months are really terrible when you're getting into the North Sea with regards to doing lifting operations, because there is basically almost never good enough weather to perform a good lifting operations. I think they're on some sites they're down to like 5% of the time during the winter months that they could actually perform lifting operations. And having a heave compensation system on your crane is going to allow you to accept worse weather than usual, so that it's going to let you operate with worse weather. So that's if you're going in at a bad time of year into an area where there is usually a lot of bad weather around that time, you're going to have to need a very well compensated crane if you're going to be able to perform any lifting operation at all. And even then you might actually have to have the vessel sitting around for a couple of days just waiting out the weather until it's a fairly calm day and they can actually perform the operation. We also need to think about if we're going to need a moon pool and guidelines, and are we going to need a module handling system. So if the module is sufficiently big, we're going to have to need a module handling system, or in some cases, for some fields, no matter what you're going to do, you have to use a module handling system because it's built that way. So the subsea modules have been designed so that they are going to be used with a module handling system. And then you're sort of locked in there. You have to have that available on your ship. And also, the vessel itself, we need to check that the characteristics of motion of the vessel itself are going to be able to perform in bad weather. So that even though we might not be able to perform the lifting operation itself, then at least the vessel can stay there for a couple of days in the bad weather, just waiting until the weather improves itself. That happens quite a lot in the bad months of the year in the North Sea, where entire vessels and crews just have to wait around for a couple of days until the weather changes a bit and they can actually perform the operation that they're supposed to do. I've been a part of at least 2 of the projects I were in Imenco, where we had a really short deadline because we needed to get something out there very quickly. They were mobilizing the ship, so they needed to get it onto the ship before the ship left the dock. And we worked our asses off to get that equipment in place on the ship. Then the ship left, and then we hear a couple of days later, once they have arrived at whatever field they were supposed to be at, the weather is too bad. And they might have to wait over a week in order to actually perform the operation. So they could have potentially just waited in the harbor and then set off when we didn't need to work that hard as we did. But still, it's something you can't know until the vessel is actually there. Because the weather, as we all know, weather changes from day to day. So even though there is bad weather while the vessel is transiting to the place of operation, it might still be changing by the day the vessel arrives, or it might have to wait for a week or 2 just to get better weather. We also need to check that we have enough cabin capacity on the vessel, because usually you're going to have to specify what kinds of personnel you need on the ship in order to perform this operation that's going to be performed. Especially if it's a diving vessel, you have pretty heavy requirements to cabin capacity because you need a lot of support personnel in addition to the divers. But also for a regular IMR vessel with just ROVs, it might be necessary to have special technicians along for this particular operation. So you might need to have room for those on the ship also. And then it doesn't really help if the regular crew of the ship basically fills up all of the cabins, then you won't have room for the special technicians that you need. And also you might have to bring along observers from, for an example, DNV, who are going to observe the operation in order to verify that everything has been done according to the rules and requirements that have been set to you. So you might have to have that also. And if you have, usually, if you're on a vessel doing an operation, you're usually working for a company like Reach Subsea or Deep Ocean or Technip or something like that, who again are working for Statoil or BP or Hydro or anything like that. Well, Hydro is out of the loop now with oil and gas. They've merged with Statoil, but we'll look at that with in the next part. But for any of these large companies, they usually hire in smaller companies that perform the operations. And that means that there might be 1 or more representatives from the large company that are also going to observe the operation in order to make sure that everything is done according to their specifications. So it's you can end up having quite a few guests, basically, on the vessel that are just there to watch. So you can feel a bit foolish sometimes when you're working in such a situation where you have 5 or 6 people that are just watching you, what you're doing. But it's the same if you're working like I did for Imenco. Whenever we had created a new ROV tool or some equipment for a project, then we would have what's called an FAT test, which is a final assembly test, or final assembly and testing. And then there would usually be a representative from the customer, at least one representative. So they would come and they would basically just watch while we were doing the final assembly of the equipment, and then while we were performing a test. If it was a lifting equipment, we needed to pull it up in a jig and actually pull it to beyond the specifications of the lifting equipment. So, for an example, if you've designed a 10-ton lifting equipment, you usually have to pull it to twice that, so you have to pull it to 20 ton just to show during the test that it hasn't been deformed in any way, even though it was at twice its capacity, basically. Because when you've designed it, you usually have, for something that is used for pure lifting like that, especially offshore, you usually have a safety factor of up to 5, so that you have a pretty hefty capacity on it. So by lifting it to twice what it was supposed to be able to do, there shouldn't be a single deformation on it at all. So it's important to have the customers come and actually watch that. Yeah, we've managed to do this correctly. And that also happens offshore for operations. We also need to check that we have the required maximum vessel size. And this is with regards to actually where can the vessel go. So for an example, maximum vessel depth, or the draft of the vessel, might hinder it in actually getting into a harbor or a dock in order to load on equipment or offload other equipment. So you have to make sure that the vessel can actually reach all of the parts where it's supposed to reach. And the same goes actually for a rig. It only says dock or harbor in this part, but the same goes for a rig, because if you have a vessel that's too deep, some rigs have legs that go out at an angle, so that you can't really come too close to it. So if the vessel is too deep, and then you might have a problem getting close enough for the cranes on the rig to actually pick up whatever it is you're carrying on your deck. So it is necessary to check that. And also, for an example, sometimes, especially if you're going to pick up large equipment in a dock, like Westcon Yards in Ølensvåg, which is towards Oslo when we're moving in here. It's in one of the fjords here, all the way in the deep end of one of the fjords, basically. And it is placed there because it's fairly accessible, so they can get in there with pretty large vessels and rigs. But I know that there have been placed other docks in other places where it's basically almost too narrow, so that very wide ships will have a problem entering. It's deep enough, so it's not a problem getting in that way, but it's actually so wide that they don't dare put those large vessels in there, because they would only have a couple of meters on each side for safety. So it's there are some places that are perfect with regards to weather when it comes to doing work on floating stuff, but they might be a bit difficult to access. Also, we need to think about the transit velocity of the vessel. So if we have a semi-submersible, it's going to use a long time in getting from wherever it is and to where it's going to perform the operation, because the transit velocity is so low. So they move very slowly. If it is a vessel, they can usually move at a couple of 20 knots, maybe even 30 knots, depends a bit on the vessel. So they can usually get there pretty quickly if it's a single hull vessel. So, but the semi-submersible are usually the ones that get bogged down with this requirement of transit velocity, because usually you need the vessel now, preferably yesterday, at the operation location. That's at least the sort of way that I'm used to being connected to stuff like this, because it's always in the very last moments that someone somewhere suddenly remembers, oh shit, we need a vessel to do this operation. we haven't gotten that one. We've planned the entire lifting and everything, but we haven't actually gotten a vessel. And then they need to hire in a vessel or something. So it's often the case, at least with smaller equipment, that they sort of figure out that they need the equipment when it's basically too late. So all of the people working at the Emenco have to throw away everything that they have in their hands, and they just have to work overtime every day in order to get this in place fast enough. So it's a transit velocity can play a huge part in the choice of vessel and just basically getting it there quick enough. But also if the vessel is it's available right now, you're going to use it in the North Sea, but it's located in Brazil. So it's actually going to have to travel across the entire Atlantic Ocean in order to get there. Then you really need some transit velocity in order to get it there. And it might be that it's some sort of special vessel, so there isn't that many of them available in the world, and the only one that is actually available to do this operation right now is the one that's that far away. Then you just have to hope that it has a fair enough transit velocity and can get there in time. Also, we need to know if there is a need for diving equipment. So do we need a diving vessel? And are there any special requirements for the ROVs or the equipment and tools that the ROVs are going to use? And if we need larger operational flexibility, so if we know that this is an operation that's going to take some while, we might have to change our crews and everything, then we're going to need a helipad in order to. So the vessel itself needs to be large enough in order to have a helipad. So that we can exchange the crews during the operation. And then we get to the additional requirements. We need to look at the vessel day rate, because of course we would want the vessel that is the cheapest one, that fulfills all of these requirements up here, and still is the cheapest one of the ones that we hopefully have to choose from. Hopefully we have more than one to choose from. And also the day rate for the ROVs or the divers or whatever extra equipment that is needed for this. It might be that you have had to hire in equipment for this one, so you need to add that day rate to it. And of course the personnel working on the ship. We need to put a day rate of those into the equation also. So it doesn't really help having a fairly cheap vessel day rate if the personnel day rate is skyrocketing, so that you're basically paying the same amount of money. It only looks a bit less because the price for the vessel itself is cheaper, but the crew they're suddenly a lot more expensive. So it can be useful to actually look at the different day rates when you're looking at it, and not the total cost. So when we're doing an operation, we're going to have a total operational cost, and it starts off with the mobilization costs. And the mobilization cost, it includes the installation of equipment. So for an example, sometimes you will actually have to weld equipment to the deck of the ship. Even though it's just temporary, just for this operation, you're actually going to have to permanently put it in place, and then you're going to have to cut it away afterwards when you're done. So that's a very, very common way of doing stuff. It's just basically modifying the vessel like this. Installing equipment, modifying the vessel itself. Maybe we need some extra capabilities on the vessel, so we're going to have to do some modifications to it. We need to train the personnel that's going to perform the operation. That's a part of the mobilization costs. It's usually done ashore before it's sent off. We need to test all of the equipment that's going to be used during the operation. And then we have to add the day rate, the total day rate of everything, and the days of operation. And for the day rate, we need to look both for the day rate of the vessel, as we talked about earlier, the equipment, and the personnel. But then we also have to add in the demobilization cost for the vessel. And the demobilization costs includes the dismantling and unloading of equipment. So if some equipment was actually welded to the vessel, you're going to have to cut that away, and you're going to have to basically return the vessel to the state it was in before this operation. So you're going to have to remove all traces of the equipment you had installed. And you're going to need to put in consumables. And consumables is basically anything that isn't covered in the day rate for the vessel and the equipment and the personnel. So lubrication oil or fuel or anything like that. So catering for the personnel is usually not included in the day rate. So all of that needs to be added up also. And only when you've added all of that are you going to get the total operation costs. So the day rate, total day rate for a vessel, including vessel equipment and personnel, and I think including consumables also. For a regular supply vessel, it can easily be a couple of 100,000 Norwegian kroner for a day. So you really you're racking up a lot of money when you're starting to especially in the bad months of the year with loads of bad weather, where you might have a vessel just sitting waiting for a couple of days. You have to pay many hundred thousands of Norwegian kroners for the vessel just to stay there and wait for the weather. So it can be really expensive doing operations like this. Yeah. I think it's under consumables if it's not covered in the day rate for the vessels, but it's going to be covered by either consumables or the day rate for the vessel, because it depends a bit if they can use regular ballast water or if they need to use something in particular. Because we don't really get into that in this course, but the naval courses that are here for whoever is the Norwegian students that are educating themselves to become ships captains and stuff like that, they get to learn quite a lot about ballast water, because you can have huge problems in the environment due to ballast water. Like, for an example, on the American East Coast, there are some I think they're called scallops or something. So it's a certain kind of crustacean living in the sea that isn't native to the east coast of America. So it's spread. It basically doesn't have any enemies, so it doesn't have any predators preying on it. So it's getting lots and lots of food available, so it's just spreading across the entire east coast of America. And the reason for this is that it is native to Russia, and Russian ships filled ballast water in Russia, just filled water directly from beside the shore there, and they caught some of these creatures in their ballast water, and they survived in the ballast tanks on the journey over to America. And once they reached America, they didn't need the ballast tanks anymore. They were going to dock and unload everything they had. So they just pumped out the ballast water in the harbor. So suddenly they had these creatures living there, and they were spreading. So you can have pretty huge environmental catastrophes in this way by introducing non-native species into an area, and then you don't have any predators for that species, and you sort of get it's the same with same history with Australia and the both the camels and the rabbits and everything that was introduced by the Europeans who colonized it. It's basically destroyed the ecosystem there, because there were no natural predators for this. So that there's just, I think the last thing I heard about camels is that there's a couple of million wild camels in Australia. So there's so many that they're actually the last thing I heard was that there's a company offering to basically just go out and hunt camels. So you can pay that company to go and hunt camels, because the camels are producing a lot of methane and CO2, so these global warming gases. So people who are driving a car and are feeling guilty about releasing CO2 into the atmosphere, they can sort of pay this company to go and hunt camels, because then at least the total emissions from Australia is going to be lowered. This is pretty crazy. And actually, they're exporting camels to the Middle East for racing and stuff like that. So it's pretty stuff that you don't really think about. It just sounds pretty idiotic, basically. But they brought them over there to Australia in order because the environment is perfect, and to use them instead of horses, because the horses were struggling with the environment because it's so dry and it's so hot. So that's why they brought the camels, because the camels were used to it. So it's a perfect living condition for the camels. So they don't mind. but they're eating up all of the greenery that the local animals should have. So it's it's a huge problem there. Right, we'll do a break. I think we're here in the next lecture also. So we'll just stay in here.